Hi, my name is Ariana Rodriguez, and this is Project 3 2D Wind Tunnel Simulation. So I'm going to start with a new fluid flow fluent project, drag it over, I'll put it right here. And then geometry, going to change this to 2D and right click, new design modeler geometry. Let's wait for that to open. I guess in the meantime can review the specifications here. So it gives us all the dimensions for the solid chamber, contraction chamber, test section, and diffuser. So I'm going to roughly sketch it out and then I will fill in these dimensions. So I want to click on the Z-axis, XY plane, sketching, and I want to draw a line that is positive axis to the negative axis. Awesome. And I want this to be centered at the origin. So I'm going to select midpoint and click on the line, then click on the origin, and it shifted the line up. Perfect. And now I'm going to add more lines, my sketches. So just to give a rough shape, and then I can fill in the dimensions myself. Great. Alrighty, and if I go to dimensions, let me see. So the settling chamber is 22 inches tall, or height, and 20 inches tall, and length is 15 inches. So I'm just going to go here, confirm my units are in inches. So this is 22. Let me zoom in. And this dimension is 15. Mm. The contraction chamber is 24 inches. The test section is 12 inches in length. The height is 6 inches. Oh, wow. And then the height, I'm going to do general. So I'm going to do between the origin and this one is going to be 3 inches. Awesome. So it'll be 3 on each side. And lastly, the diffuser is 42 inches and it has a half diffuser angle of 3 inches. So I'm going to make this 42 inches. Wonderful. Alrighty, and then I can go here, angle, and then between these two on this side, we want it to be 177. So it's 180 minus 3 degrees. Perfect. So here we have half of our shape. And now there's an option to duplicate. So I want to select points or edges. So I'm going to go, yep, perfect. And select, I don't actually want that one. Alrighty. And then I'm gonna hit enter. Oh wait, let me duplicate, make sure everything is selected again. Hmm. Duplicate selection. No edges or warning, no edges or points used must be from plain. Okay. Let me try that one more time. Hmm. Not sure why it's not letting me duplicate it right now. Maybe if I copy it, Control C, and then I just Control V. Perfect. Okay. And then what I'm going to want to do is flip vertically. There we go. So now we have the opposing shape and we can just lock it right there. And then I'm just going to right click and press N so that I don't have that copy anymore. And I just want to go through and confirm my dimensions and that this was actually copied correctly. So I'm going to go back to dimensions, general. So this should be, which is L2 right now, it's 15. L8 is also 15. The contraction length, L9, is 24, which matches 24. This one is 10. Oh, sorry, it's 12, which matches 12. And then lastly, the diffuser length is 42. 42, perfect. So I just want to confirm the general length here between here. Oop, let me undo that or undo. Vertical between here and here is 6. So V13 is 6. Awesome. And then we just want to draw our final line to finish our shape off. So I'm going to connect here to here. Awesome. Now we want to go to modeling, right click, sketch one, and then create our concept surface from sketches. So I'm going to apply sketch one. Perfect. Let me see if it lets me generate. Awesome. So now we have our geometry. So I'm going to save here. And then close to go to the next step. So over here, we can now move on to the mesh. Okay, so now here we have our mesh and we want to right click, insert method. Geometry, we're going to select our shape, hit apply, and method, we want to be triangles. Awesome. And then I'm going to go to the mesh. I'm going to change the element size to 0.01. There we go. And now I'm going to generate. So now I should have a mesh of triangular elements, and we can see that here. Awesome. And then I want to add named selections. So I'm going to click the edge selector and then control click. And I'm just clicking every edge that is not the inlet or outlet. So this is going to be our walls. So then right click, create name selection. So I'm going to say tunnel wall. Okay. And then this is, or press letter N, inlet. And this is our outlet. Awesome. So now we have our name selections here, our tunnel wall, our inlet, our outlet, and then our mesh is all set up. So now we're good to move on to the next step. So if I see here as well, just before I simulate, um, so it's simulating viscous laminar flow, and we're supposed to do it for three different frequencies, and we're given a formula to find the velocity of the test section based on our frequencies. So viscous laminar flow, and then I have that specified here. So I'm gonna go make sure my message is updated. So right click update. Perfect. And now we can go to setup. So I'm gonna say double precision, and I want two solver processes. Start. I have to wait for this to load a little bit more. And then our report doesn't specify like viscosity or density, but I'm going to be doing it for air, and I'm going to be keeping what ANSYS, the standard ANSYS one. So the density is going to be 1.225, and the viscosity is going to be 1.7, can't remember the rest of the numbers, times 10 to the negative 5. So starting at models, energy, want to turn that on. And then here, we want to change our flow to laminar. Perfect. Want to now move on to our fluid. Just want to confirm air. So yeah, 1.225 and then 1.7894 times 10 to the negative 5. So change and create, close that. And then our boundary conditions we see here. So there's the inlet, so velocity inlet. So maybe, there we go. So I have the formula here. So this is what was given, and we are doing this for different frequencies. So I have the different frequencies here. I'm going to show 60 hertz, and then I will show 20 and 40 since I've already done those cases before. But plugging 60 hertz into this equation, I get the velocity of text session to be 14.5622 meters per second. But we want the velocity of the inlet here. So we're using the we're using the continuity equation. And so because this is a rectangular shape, we would just have the height of the test section over the height of the inlet times the velocity of the test section to find the velocity of the inlet. So following this equation here, I end up with this velocity here of 3.971509091 meters per second. So I'm just going to oops, copy the value and let's see if it lets me drag it in. If not, I will have to. Perfect. There's the value, and I'm going to hit apply, apply, close. Alrighty. The outlet is a pressure outlet and the tunnel wall is a wall. All right. I just want to confirm my reference values before I run. So we have everything here. And if I compute from the inlet and body. Okay. So now I'm going to go and initialize. I'm just going to initialize one more time just to confirm. Okay. And then I'm going to run calculation. So I'm going to do 300 iterations, although I don't think it needs that many. Great. So now we can create our contours and our profiles. So starting with contours, we want to find the velocity, static pressure, total pressure, dynamic pressure contours in the wind tunnel. So I would go to graphics, contours, right click, new. Perfect. And so pressure, I'll start with velocity and we can work our way back. Perfect. And I'm going to hit save and display. And here is our velocity contour. So you can screenshot this and this would be in the report. So same for pressure, static pressure, save and display. We also want our dynamic pressure, save and display. And lastly, our total pressure. Sweet. And now if we wanted to see the profiles, we're going to go to plots, XY plot, and right click new. And so starting with velocity again, velocity, velocity, magnitude, direction vector, and we want it, oh, actually I'm missing a step. You're required to plot the variation of velocity, static pressure, total pressure, dynamic pressure along the wind tunnel center line. So I have to create a center line first. So in order to know how far, like to create the center line, I need to know how far across I need to make a line. So I'm just going to minimize this window really quickly, go to my workbench, and I want to open up my geometry again. That way I can just measure the distance from the inlet to the outlet. So I'm click Z, and go to Tools, Analysis Tools, Distance Finder. So I'm going to select, oh, make sure your edge select is on for that. So I'm selecting the inlet, apply. I'm also going to select the outlet, apply. And that's in inches. I actually want that. Let me, units, meters. Let me do the distance one more time. That way it is in meters. Distance finder, edge select, inlet, outlet. So the distance is 2.3204. So I can close out of this. Remember 2.3204. So surfaces, insert, right click, new line, 2.3204. Okay. And create. So now we have a center line, which we can see here under our surfaces. So now if I go back to the XY plot, I can plot at the, let me rename that. Center line. Perfect. So right click XY plot, new. I'll go to velocity, start with velocity. Velocity is the y-axis, the x-axis is a function direction vector. Perfect. So I'm just gonna click center line, save and plot. And so here is our velocity profile. Now pressure, static pressure, dynamic pressure, and total pressure. And we're saving and plotting here, but if you want to write to file, you would click here and then select write. And I like to select all files. Let me actually go to the folder I wanted in. And so here I would save it, a naming scheme like this, and then .csv. And you can open that in Excel since we're asked specifically to make our plots in Excel. Perfect. So this is, yeah, the simulation breakdown for 60 hertz. So I'm going to close out of this and I can show you my results for 20 hertz and my results for 40 hertz. So I just want to save this project in the meantime, just because I did. I'm also going to rename this. Wind tunnel 60 hertz. Perfect. So now if I go to my setup, actually, let me make sure my mesh is just updated because I did look at something earlier and I don't think it'll be happy if we progress without updating. Perfect. So now I'm going to go to the setup, build precision and 2 were selected from before. So now in this step, everything is going to be the same except for the velocity at the inlet. So again, using the equation, I plugged 20 in here, found the velocity of the test section, and then plugged in my values over here. So this would be 6/22 times the velocity of the test section. So I found my inlet velocity to be this number here, 1.256236,364. But otherwise, the setup is the same. We have energy on, our flow is laminar. We have our boundary conditions set up, but now there's gonna be a different velocity, so I'll show that. Our fluid is still air, and then I can just run it really quickly and show my results. So if I go models, energy on, laminar, material, fluid is air. Boundary conditions, the inlet velocity, like we were saying, is going to be that 1.2 decimal. Yep, there it is. Close. Reference values at the inlet. Want to, I wonder if it shows the graphs now. No, it's not. Okay, I'm going to initialize to run it real quick. So we can right click, new. So if I save and display, we have our static pressure, dynamic pressure, and total pressure, as well as our velocity profile. And then going to right click, new. I already have center line. I did it before. So center line for static, save and plot, dynamic, and total, and velocity. Save and plot. Again, you would write to select write to file, and then it would write to save to Excel. And finally, I will show you very briefly what I did for 40. Again, everything is the same except for the velocity. So I'm going to go to my setup. I'm just going to double check to see if there's anything else I need to show. Graphs generated in Excel. Perfect. I showed all the contours, all the velocity profiles. Okay. So again, I'm just going to go through and confirm my setup where energy is on, flow is laminar. Going to change my inlet velocity, make sure that my fluid is still air, and then I will run it and then show the results I got. Energy on, perfect. Materials, the fluid is air. Boundary conditions, inlet velocity, let's see what it should be. 2.6138. What popped up right here? Perfect. So we can see that there. Apply and close. Um, we've got our outlets and control. Okay. So now I just want to confirm the reference values at the inlet. All right, and then we can initialize. Initialize. And then run calculation. Okay, so graphics, contours, new. So there's static pressure, dynamic pressure. Oops, I didn't apply static pressure. Static pressure, dynamic pressure, and then the total pressure, as well as the velocity. And then we can go right back down to the plots and see it all again. New. And we want to select center line. Oops. Side pressure, dynamic pressure, and total pressure, and the velocity profile. Perfect. Well, thank you so much for watching how I did my third project for fluid mechanics 2D one tunnel simulation. I hope this is helpful to anyone watching.